Alright, so this presentation is going to be over summary statistics for quantitative data. We will be going over how to calculate mean, median, range, quartiles, interquartile range, percentiles, variance, and standard deviation. So first up, mean. The mean is found by adding up all of the values in a list. So you have a list of numbers. You add them all up and you divide by the number of items you have. So for example, let's say I had a list of how many times somebody ordered a large drink at Taco Blanket, right? Within a given hour, maybe. I don't know. Maybe I could keep track of all of that, how many times somebody ordered that large drink. So what I would do, if I wanted to find the average or the mean, is I would add up each of those tallies, right, and divide by how many measured. So maybe here's a list, right? So maybe throughout the course of a really long shift, or maybe two shifts together, I have 13 measurements of how many times somebody ordered a large drink, right? 3, 4, 6, 7, 9, 1, 6, 8, and 4. If I wanted to know the average number of people who ordered a large drink, what I would do is I would add all of these values together and divide by how many different measurements I took. Since I have 13 measurements, I will divide by 13. That doesn't do me much good. There you go. My average is 5.84615. So on average, a little less than 6 people per hour ordered a large drink. The median. So in order to find the median, what you have to do is write the numbers in order, and then find the value in the middle, right? If it's a long list and you don't, well, I mean, it can be tricky, finding what's in the middle. Surefire way to do it is to find how many values you have in your list, add 1 to that number, and divide that by 2, and that will be the value, the location. So first you have to put them in order, which it can be tedious, but alright, so now that we have them in order, again, there's 13 numbers in this list. So if I go based on my formula that I have here, I add 1 and divide by 2. So 13 plus 1 is 14. 14 divided by 2 is 7. So the 7th number in this list will be my median. So 7, there's my median, right? My median is 6. Median. So range. Range is very easy, right? Range, all you have to do is find the lowest value and the highest value, the minimum and the maximum, subtract them from one another, and that is your range. If I look at my list, it's especially easy now that I put everything in order. My list, the smallest number is 1, the biggest number is 13, so my range is 12. 13 minus 1 is 12. Now, to find quartiles, quartiles are a little bit tricky, but once you've found the median, it's not that bad. So my median is right here. According to my instructions, first I find the median, then I find the median of each half of the data, right? So my minimum value, so the median will be each, the Q1 and Q3 will be halfway between the very beginning of the list and my median, and then the very middle of the list, or the very end of the list and my median. So when we're looking at the data, so if I ignore this and I'm only looking at the first half of the data, my median is halfway between the numbers that I have here on the left side of my median. So 4, 5, 6, there's 6 numbers, so halfway between the third and fourth one. Now, just like in the instructions for the median, if it's halfway between 2 numbers, you add them up and divide by 2. So halfway between 3 and 4 would be 3.5, so 3.5. So Q1 is, I do the same thing over here for Q3. I have, again, 1, 2, 3, 4, 5, 6 numbers. Halfway between the third and the fourth one would be 7.5, so the midpoint of the 5. So my median is 6, my Q1 is 3.5, and my 7.5. Then for Q0 and Q4, or the minimum and maximum, I just look at the smallest and the biggest numbers on that list. So my Q0, or my minimum, is 1, and my maximum, my Q4, is 13. So the 5-number summary, which is something we'll refer to later, is these 5 numbers. My minimum, which is 1, my Q1, which is 3.5, my median, or Q2, which is 6, my Q3, which is 7.5, and then my maximum, or Q4, which is 13. And there's my 5-number summary. We'll get into that a little bit more once we get into the box. The interquartile range is just, it's like finding the range, but it's for Q3 and Q1. It's another measure of spread that we use, right? So I find Q1 and Q3, and then I subtract, and that is my interquartile range. So for us, Q3 was 7.5, Q1 was 3.5, 7.5 minus 3.5 would be 4. So my IQR, or my interquartile range, would be 4. Now, the only reason you would do this, well, not the only reason, but a major reason you would do this would be to find whether or not something is an outlier. Now, an outlier is defined as something that is so far away from the rest of the data that you can almost ignore it, right? It's so unusual that you wouldn't really consider it as something worth calculating with everything else. It's evidence that something weird's going on, right? So when I'm looking at this data set, really everything is close to around the same except for this 13, right? This 13 is kind of far away from the rest of the data. So maybe it's an outlier, right? The way to find that out is to take the interquartile range that we just calculated, 4, multiply that by 1.5. Okay, so 4 times 1.5 would be 6. And then add that, either add that to Q3 if we're looking at the top side or the top end, or subtract that from Q1 if we're looking at the bottom end, right? And then if our value is further away from Q3 than our number allows it to be, then we consider it an outlier. So if we're looking at our data set, right? The IQR was 4. 1.5 times 4 would be 6. And we add that to our Q3. So Q3 was 7.5. 7.5 plus 6 would be 13.5. If our biggest number is, if any of our numbers are bigger than 13.5, then we can consider them outliers and just blow them off completely. Thankfully, this 13 is not bigger than 13.5, so it is not considered an outlier. We don't have to. All right, percentiles. Percentiles hit close to home for me because there was a question on the AP test the first year I taught AP statistics that was all about percentiles and calculating percentiles for individual data. And since I didn't stick on it very much when I was first teaching it, my students didn't remember how to do it. It's one of the first things we learn, and the test is at the very end of the year. They didn't remember how to calculate them, and some of them just blew the question off completely. Unfortunately, it was question 6, which is worth a large chunk of their overall score, and so most of them did not. So let's focus on percentiles, right? So the way you calculate a percentile is similar to the way you calculate where the median is, right? If I want to know, say, the percentile score for this, what I would do is I'd say, okay, well, out of the 13 values I have in my list, what location is this 8? It is the 11th number, right? So the percentile score would be 11 over 13, because it's the 11th number in the list out of 13, and then that value, whatever that proportion or that fraction is, multiply it by 100, right? So to do that, so to find that, I do 11 divided by 13 times 100, and there you go. The percentile score for that 8 is 84.6, so it's in the 84th or 85th. All right, now variance and standard deviation. These are two that we use a lot. They're sort of referred to interchangeably because the way you get from variance to standard deviation is you just take the square root of it. The way you get from standard deviation to variance is you just square it, so you can kind of bounce back and forth between the two of them pretty easily. Now, to calculate them by hand, it is very tedious though. What you have to do is for each of your data points in your list, you subtract them from the mean. You then square each of them and divide each of them by the number n minus 1. N referring to the total number of things in your data set. N minus 1 for us would be 12 since we have 13 in our data set. So, I mean, might as well go ahead and get it done, right? So the formula, I guess, would be, I'm going to leave a blank here So something minus our mean, excuse me, squared, and then divided by n. Our n is 13 minus 1, right? So what you have to do is plug in each of the values for for our data points in this list, and then add up all of the results. And the sum of all of the results of these calculations will be your variance. So I'll go ahead and get started on that. All right, and there's our variance, 10.141. That was a lot. All right, so in order to calculate the standard deviation from that, thankfully, we don't have to go do a whole new calculation. All we have to do is take the square root of the variance. And do that. Variance, there's our standard deviation. Much easier, right? Now, so we've done all this. Now you know how to do all these by hand. If you have one of these calculators, though, there's a much faster way to get most of these. You can get the mean, median, min, Q1, median, Q3, max, and standard deviation all very quickly from our one variable statistics over here on our list of spreadsheets. So I've entered all of these same numbers in this list. There's 13 of them, right? I've named the list X just because I felt like it. I go to Menu, Statistics, Stat Calculations, One Variable Statistics. I make sure I have the correct list selected, and I see that here's my mean. My X bar is 5.8415, just like we calculated. And there is my standard deviation, 845. I have 13 values in my list. There's some other stuff here too that we'll get to later. Here's my minimum, Q1, median, Q3, and max. And yeah, there's all the information we had, right? So if you are using one of these calculators, that's significantly faster. It'll save you a lot of time. Even if you're just asked to find the standard deviation of a list, you can do it this way by typing them all in that way. So a lot easier. And yeah, that's everything. That's quantitative summary statistics. There we go. That's what I was trying to do. There you go. Hope this was helpful. Bookmark this for later, huh?